Howdy. We have not had that greeting on notes. Howdy. Hello, how's it going? Today we are going to be doing some notes where we are talking about similar shapes and proportions. Like we already talked about, if things are similar, we're going to use that little squiggly line that looks like that to show that they are similar. In these notes, we're going to look at some different shapes and decide, are they similar shapes or are they not? So in case you forgot, similar figures are figures that are the same shape, but they are different sizes. Same shape, but different sizes. Like we've talked about before. Let me get my backpack. Oh, I took them back to school already. Never mind. Like I showed you before, we had those different size glue sticks where one was they look like this. I got one here. They look like this, where I had this smaller one, and then I also had, it looked the exact same, just bigger. Those are similar figures. They're the same shape, they're just different sizes. Remember the two things that you need to know about similar shapes is that their corresponding sides are proportional. Corresponding sides are proportional. Remember, corresponding sides, those are the sides that match. Corresponding sides are the sides that match. So for example, if I have like these two shapes, if I have those two shapes, this side here is going to correspond with that side there. This side here is going to correspond with that side there. This little guy up top is going to correspond with that little guy up top. And the line on the bottom is going to correspond with that line on the bottom. They match each other. They're in the same spot on similar figures. So we have that corresponding sides match. And then we also need to remember that corresponding angles are equal. Corresponding sides are equal, or corresponding angles, excuse me. Corresponding sides, those were the sides that match. So corresponding angles then are going to be the angles that match. So for example, this angle at that dot is going to match the angle at that dot. The angle at this little star is going to match the angle at that little star. The angle at this little triangle is going to match the angle at that little triangle. And the angle at this little horizontal line is going to match the angle at that little horizontal line. They match. They're in the same place on similar figures. That was a quick review. Now we want to get into looking at two shapes to determine if triangle ABC is similar to triangle XYZ. How do we show similar to mathematically again? We do that little squiggly line, like on the top of ends in Spanish. To triangle XYZ, we can write a proportion for each pair of corresponding sides. We can also just divide. So I'm going to show you guys two different ways that you can do that. Or no, we'll just show one. And if you're not liking this first way, let us know. We can show you another. So first off, I need to go through my two shapes and I need to highlight my corresponding sides. think it's usually easiest to start out with either the longest side or the shortest side. In this case, I'm just going to do the longest side. So if I look at this one, this long piece right there, that's my longest side. What does that correspond with on this shape? The 15. Those two sides correspond with each other. They're both my longest side. Then let's take a look at the middle side. Which of those lengths is going to be the middle length? That 12 on the bottom, that's my middle length side. And over here corresponds with 8. That's the middle length side. So that means my shortest side is going to be what's left over, the lines on the left. Those sides all correspond with each other. If you don't have the highlighters to highlight, I suggest that you use colored pencils too and just draw your colored lines, because that's going to help you when we're trying to set things up over on this side. That doesn't seem very focused. There we go, that's better. So when we're trying to determine if these two triangles are proportional, we want to set up a ratio and see if they all simplify to the same number. So if I have the longest side, I first want to start out with a word ratio. We've talked about these before. And here, what I'm comparing is a smaller shape and a bigger shape. So for my word ratio, I'm going to put my small number on top, and I'm going to put my big number on bottom. When I say small number and big number, I'm talking about the shapes. This is my small shape, and this is my big shape. Now that we have our word ratio down, we're going to want to fill in the side lengths. Now we want to fill in the side lengths. So I'm going to take at my look at my long sides, my 10 and my 15. I said I want the small shapes number on top first. What's my small shape number? 10. 10 is my small number for my longest side. 15 is my big number from the bigger shape. Now that I have my ratio, I can simplify it. There's two ways that you can go through about simplifying it. One way, I divide my numerator and denominator by a common number. So what number goes into 10 and 15? 5. So I can take 10 divided by 5 and 15 divided by 5. What's 10 divided by 5? 2. And what's 15 divided by 5? 3. So we simplified it to 2/3. We could also use our calculator and just do 10 divided by 15. And we see that we get 0.6 repeating. It does not matter if you do the fraction or the decimal form, but whichever way you decide to do it, you've got to be able to do it that way for all the side lengths. If these two triangles are proportional, these numbers will be the same for the long, middle, and short sides. It's going to have a constant number there. So let's go on to the middle side. See if it's still true. Again, we want to start out with our word ratio. Since we started with small over big, we need to keep doing big over small the whole way through. We need to keep doing small over big the whole way through. So we're going to put our small blue side on top and our big blue side on the bottom. So looking back to our similar figures, what was our small blue side? 8. What was our big blue side? 12. So we get 8 over 12. Again, we can't just leave it like that. We need to see if they all simplify to the same thing. So let's use the division way first. What number divides into 8 and 12? 4. So I can do 8 divided by 4 and 12 divided by 4. What is 8 divided by 4? 2. What's 12 divided by 4? 3. So far we match. Again, you can also use your calculator too. That's totally fine. 8 divided by 12. And we get that 0.6 repeating again. Same thing. We have to check every single side because they might all be right until the very last one. So now we've got our short sides. We've got our pink sides. Again, however we start out our ratio, we have to do it the same way the whole way through. So we're going to put our small pink side on top and our big pink side on the bottom. Go ahead and pause the video. Try doing this one all on your own. Fill in the fractions and simplify it or divide it for me. All right, your small pink side should be 6. Your big pink side should be 9. 6 and 9 are both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Or if you type it in your calculator, you get 0.6 repeating. So now we got to check. Do we have the same number all the way through? Yes. It is the same number all the way through. So they are proportional. They are similar figures. So the way that we would write that was we write triangle, and then we have to name them X, Y, Z. You want to go in alphabetical order. Is similar to, so that's that squiggly line, is similar to triangle A, B, and C. Go ahead, pause the video if you need to catch up on any of those things. But if you're ready, go ahead and go to the next part. If you need a break, go get some water. Come give me, Mr. Snook, Miss Lamphere, Miss Prada a high five. But otherwise, go ahead and go on to the practice problems at the bottom. So we need to go through, just like we did up here, and tell whether the shapes are similar. And then we need to explain our answer. How do we know that they are or are not similar? So like we did up here, first thing you want to do is highlight those corresponding sides. Like we did before, I'm going to start with the longest side. What's my longest side on this big shape? 16. What does that correspond with on this shape? The 8. This 12, the middle side, what does that correspond with? 6. And then the last two sides, obviously the short ones correspond with each other. So now, this is my big shape because its size is bigger. And this is going to be my small shape. I need to keep that in mind when I'm setting up my proportions or my ratios. So let's start off with our longest side again. Taking a look at the longest side, the orange side. Last time we did small over big. This time let's do big number over small number. It doesn't matter if you do big or small on top or bottom. It just matters that it's the same for every single line. So what was my big orange side? 16. What was my small orange side? 8. We need to simplify that. Some of you guys can probably do that in your head. What does 16 over 8 simplify to? 2. Boom. That's easy enough. Let's try the middle side. Again, because we started off with big over small, we have to keep it the same way. We gotta do our big blue side over our small blue side. What was my big blue side? 12. And what was my small blue side? 6. Again, some of you guys might be able to do that in your head. If you need a calculator though, that's fine. Pause the video, divide it out. But what's that going to simplify to? That is also simplifying to 2. Woo, this one's not too bad. One more. We got our short side. We got our shortest side. Go ahead, pause the video, set this one up on your own. Set this one up on your own and tell me if if these are proportional. Similar figures, are they proportional to each other? You should have done 10 over 4, which simplifies to 2.5. So are these shapes similar? No, they are not. We have 2, 2, 2.5. So we would say no, the shapes are not similar. The shapes are not similar. They do not simplify to a constant ratio. They do not simplify to a constant ratio. They are not similar. I want you to go ahead, try number 2 on your own. Try number 2 on your own. Pause the video. Use your colors to highlight, set up your ratios, and simplify. If you have any questions or you want us to walk you through the problem or let you know if you're on the right track, please raise your hand and let us know. So when you go through and do this, if you did small side over big side like I did, you should get that they all simplify to 3/4 or 0.75. But if you did it the other way, if you did big over small, for each of them, you should have gotten 4/3 or 1.3 repeating. Either way you do it, it's the same across the board. They're all going to have the same ratio. So are they proportional? Yes. They are proportional. They are similar because the ratio of the side lengths is equal. So we would again say triangle PQR is similar to, how do I draw similar? The squiggly line is similar to triangle FGH. Go ahead, pause the video if you need to. If you have any questions, ask us. Or if you want to check your work, like I said, if you did it the other way, if you did big over small. But if you're ready, go ahead and go down to the last bit. Problem number 3. I want you to try that whole thing all on your own. Oh wait, no, I'm going to show you another way. We're going to show you another way. So the second way that you could do this, again, if you're good with this, just pause the video now, solve the problem, skip ahead to the answer. But if you want to see another way for it, I can show you another way. We're still going to start off with highlighting our corresponding sides. So I've got my long side, my middle side. And I got my short side. Another way that you can do this is by setting up ratios to see if the side lengths match. So what I'm talking about is I can set up a proportion. I'm still going to compare my big and my small shapes. I'm still going to start off with a word ratio. I'm going to put my big sides over my small sides. It does not matter big or small, which is on top or bottom. I just am doing big this time because I feel like it. So I'm doing big over small. And then we want to set up a proportion to see if what the side length should be, if they're proportional, is what that side length actually is. So you need to pick two colors that you want to compare for sides. On this one, I'm going to use my blue sides. So to remind myself, I'm going to put a blue highlighter mark there. And my green sides. So I'm going to use a green highlighter mark there. I'm going to fill in 3 pieces of information. Only 3. So my big blue side is 54. My small blue side is 18. My big green side is 72. My small green side, I'm not going to put in there. I'm going to leave as an X. We know it's 24 in the picture, but if these two triangles are not proportional, we will get a different number for X if they are not proportional. So I need to solve for X to figure out. If I get 24, then we're good. We just need to check the yellow side. But if we do not get 24, then that means they are not proportional. So I would take 18 times 72, cross multiply. We get 1,296. We need to divide that by 54. And we do indeed get 24 for that green side length. So far so good. We still have to check with the yellow side. So I have to set up one more proportion. I'm going to do my big over my small still. And like I said, this time we have to use yellows. This time we have to use yellows. So let's keep the blue like it was last time. Let's keep the blue. Now we're just checking for yellows. What was our big blue side? 54. The small blue side was 18. Our big yellow side, let's do our big yellow side as X this time. And then our small yellow side was 12. Again, we're just checking to make sure that 36 is the right number that it should be. If X is 36, then that means these two are proportional. So we're going to cross multiply. So 54 times 12, we get 648. We then have to divide by the 18 that's left out, and we get 36. Did I type that wrong? 54 times 12, divide by 18, 36. Oh, duh, Andrea, duh. So 36. Does 36 match that missing side length we were trying to find? Yes, it does. Just like 24 matched that side length we were trying to find. So since these numbers match with those sides, that means that these shapes are proportional. So we would write yes. The ratio we solved it a different way. So we would say this time the proportions of side lengths. The proportions of side lengths equals the missing sides. The proportions of side lengths equals the missing sides. So how would we write that mathematically? Triangle what? You want to name it alphabetically, so we'd say JKL. Triangle JKL is similar to, what's the other triangle's name? XYZ. For this last problem, number 4, oh wait, sorry, hang on real quick. If you solved it the other way, again, you're setting up your proportion and you get that this answer is 3 every single way you solve it. So yes, the ratio of the side lengths is equal to a constant ratio. So triangle JKL is similar to triangle XYZ. Right, the triangles in there. Alrighty. Oh, spoiler alert, y'all saw that last one already. With this number 4, we have our 2 shapes. If we highlight our corresponding sides, we see that those tops are both 13. The sides are all 13. Everything matches up, doesn't it? But are those 2 shapes the same? No, why not? How can you tell? Those corresponding angles must be equal. They must be equal. So if I take a look here, oh, excuse me, I burped a little bit. Does this angle match this angle? No. 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 It only takes one of those angles to be wrong for it not to be similar figures. So in this, no. The shapes do not have equal corresponding angles. So even if all the sides work out, you have to check the angles too. If the angles are not equal, if they don't match, they are not corresponding shapes. They are not similar figures. Again, if you have questions on any of this, please let us know. But if you're good, go ahead and move on to the practice.